July 14, 1944. 3 miles southwest of St. Lo, France, Lieutenant General Omar Bradley stood with his arms folded, observing a Sherman tank retreat from a hedgerow that had halted American progress for 6 weeks. Around him gathered a small cadre of officers, including Major General Leonard Darrow, commander of 5th Corps, and several ordnance experts called to witness what might become either a breakthrough or another failed experiment. Affixed to the front of the tank were 4 steel spikes that jutted forward like tusks, a device so rudimentary that Bradley had initially dismissed the report when it reached his desk. Yet desperate circumstances demanded bold solutions, and the American breakout from Normandy teetered on the edge. The tank's engine thundered to life. The driver engaged gear and charged directly at the ancient earthwork. 10 mph. 15. The steel spike struck the hedgerow with a sound reminiscent of tearing canvas, a noise destined to become familiar to American tank crews across France in the ensuing weeks. Soil and roots erupted upward in a fountain of debris. The tank neither climbed nor tilted. It surged forward, its spikes slicing into the base of the hedge like massive knives through thick fabric. And in under 5 seconds, the Sherman emerged on the far side, trailing broken branches and shredded vegetation but otherwise intact, its belly armor untouched by enemy fire. Bradley's aides erupted in cheers. Ordnance specialists rushed to inspect the hedge, measuring the breach and examining the tank for damage. Bradley himself remained silent momentarily, already calculating the implications. If this contraption functioned reliably, could be mass-produced, and installed on sufficient tanks before the planned offensive, then Operation Cobra might succeed. Perhaps the stalemate could be broken. He turned to Lieutenant Colonel John Medeiros, his chief ordnance officer, and issued words that would shape the war's course. I want these devices fabricated and mounted on as many tanks as possible. Every Sherman, every Stuart, every tank destroyer we can modify. I want them ready before Operation Cobra launches. Round-the-clock production. Utilize every ordnance unit, every maintenance facility, every welder available. This is top priority. What Bradley had witnessed was the solution to a dilemma that threatened to turn the largest amphibious invasion in history into a bloody deadlock. For 6 weeks, the hedgerows of Normandy had bested the most powerful army ever assembled. These earthen barriers, forged over centuries, had proven tougher than German concrete bunkers, more effective than minefields, and deadlier than the Atlantic Wall itself. And the man who devised the solution was not a veteran general, nor an MIT-trained engineer, but a 29-year-old sergeant from New Jersey who improvised a fix using scrap metal salvaged from German beach obstacles and nothing more sophisticated than common sense and a welding torch. This is the account of how Curtis Coulin's simple welding innovation broke the Normandy stalemate within a week and opened the route to Germany. 300 meters away, Supreme Commander Dwight D. Eisenhower paced in his headquarters at Southwick House near Portsmouth, scrutinizing maps that conveyed a story of mounting crisis. It was mid-June 1944. The D-Day landings, executed days prior, had surpassed the most optimistic expectations. Despite catastrophic casualties at Omaha Beach, where American forces nearly were repelled, by nightfall on June 6 over 150,000 American, British, and Canadian troops had secured positions along 50 miles of French coastline. Within a week, the Allies had landed over 300,000 troops and established a continuous beachhead from the Cotentin Peninsula to Cannes. The greatest amphibious assault in history had breached Hitler's Atlantic Wall. Fortress Europe, once proclaimed impregnable by Nazi propaganda, had been penetrated. Yet the maps revealed a grimmer reality. While the beaches were secure and supplies flowed ashore via the artificial harbors at Mulberry and directly over the sands, inland progress had nearly ground to a halt. By mid-June, 2 weeks after D-Day, Allied forces controlled a beachhead barely 20 miles deep and 50 miles wide. Over 1 million troops were ashore, but trapped in a narrow coastal strip, sustaining heavy casualties daily, facing the real prospect that the invasion might devolve into the static trench warfare reminiscent of World War I. The grand strategy, devised over 2 years, envisioned a swift breakout. British and Canadian forces would seize Cannes, a key road and rail hub, on D-Day itself and push south into open terrain. American forces would traverse the Cotentin Peninsula, capture Cherbourg within 9 days, and pivot south toward Brittany. Within 2 weeks, the Allied penetration was supposed to extend 15 miles inland along a continuous front. Mobile operations, rapid exploitation, armored thrusts into the German rear, this was the plan. Instead, the Allies were mired in brutal close-quarters combat, advancing by yards rather than miles, losing thousands of men for minor territorial gains. The culprit had a name: the Bocage, the hedgerows of Normandy. June 7, 1944, 24 hours after the successful landing at Omaha Beach, soldiers of the 1st Infantry Division, the Big Red One, pushed inland. Exhausted by the landing, having suffered nearly 2,000 casualties, they anticipated encountering retreating Germans or hastily erected defenses. Instead, they faced a natural maze crafted over centuries, a green labyrinth deadlier than the concrete fortifications they had just overcome. Private James Henderson of the 26th Infantry Regiment wrote in his diary, later archived in the National Archives, "We thought the worst was behind us after the beach. We had beaten the Atlantic Wall. We had survived Hitler's fury. Then we came to these hedges, these cursed Norman hedges. God help us. God help us all." These hedgerows were unlike anything American soldiers recognized. Not suburban shrubs, not simple farm fencing. They were ancient fortifications, built and reinforced over centuries by Norman farmers. Stones cleared from fields were stacked along boundaries to mark property and contain livestock. Generations added earth, seeds took root, trees sprouted, forming earthen banks 3 to 12 feet high and 1 to 10 feet thick. Roots penetrated deeply, reinforcing the walls far beyond what most man-made fortifications could achieve. Oak trees, hawthorns, brambles, wild roses, and thorns intertwined into barriers rising 15 feet above the base. Roots extended 10 to 15 feet deep, creating a reinforced structure resistant to digging without power tools and impervious to standard explosives without revealing positions. These hedgerows enclosed irregular fields averaging 200 to 400 yards across. Some square, others narrow or triangular, shaped over centuries by inheritance laws and farming practices. Aerial reconnaissance before D-Day revealed nearly 4,000 hedged fields in just an 8-square-mile sector. Each hedgerow was a fortress, each a defensive position invisible until it opened fire. Machine gun teams could occupy earthworks with narrow firing slits, shielded from artillery, protected from observation by foliage. A soldier behind a hedger was safer than in a visible pillbox, creating overwhelming defensive advantages. Single German squads could dominate entire fields, holding off companies of 200 Americans for hours. German defense did not rely on continuous lines but on strategic placement, creating interlocking fields of fire. Approaching soldiers faced pre-targeted killing zones, ambushed sunken lanes, and obstructed passages. Sherman tanks, intended for mobile operations, were rendered ineffective against these fortified hedgerows. Their 75mm guns could cut the vegetation above, but the reinforced earthen root systems prevented passage. The earthen base remained intact. Tank commanders, frustrated and desperate, began attempting to breach obstacles by brute force. They would back up to get a running start, then accelerate directly at the hedgerow, attempting to use the tank's weight and power to smash through or climb over. This tactic was suicidal. When a Sherman attempted to ride up and over a hedgerow, the front of the tank would rise as it climbed the earthen bank. The tank would tilt backward at an angle of 30 or 40 degrees. This exposed the belly of the tank, the underside between the tracks, which was protected by only 1 inch of steel armor. This armor was designed merely to resist mine fragments, not to stop anti-tank weapons. A German soldier with a Panzer, the shoulder-fired anti-tank rocket that was issued to German infantry by the thousands, could position himself in the next field and simply wait. He would hear the tank engine roaring as the Sherman climbed the hedgerow. He would see the front of the tank rise above the vegetation, and when the belly armor was exposed, he would fire. 1 rocket was usually sufficient. The Panzerfaust could penetrate nearly 6 inches of armor against the Sherman's 1-inch belly plate. It was devastatingly effective. Lieutenant Colonel Wesley Yale commanding a tank battalion in the 2nd Armored Division lost 4 Sherman tanks in a single morning attempting to breach hedge near the town of Eisen. 4 tanks destroyed, 4 crews killed or wounded, 16 men dead or injured, and not a single successful breach. His after-action report filed on June 15 captured the frustration and rage felt by every American armor officer in Normandy. The enemy need not even see our tanks to destroy them. They position themselves in the next field behind the next hedgerow and simply wait. They listen for the sound of our engines. They hear us climbing the obstacle. And when we reach the top, when our belly is exposed, they fire. We are losing crews and machines to an enemy we never see, never engage, never have a chance to fight. Our tanks, which should be our greatest advantage, have become death traps in this cursed country. American forces tried every solution their training and doctrine suggested. Combat engineers trained in demolitions and obstacle clearance were brought forward to blow gaps in the hedgerows using explosives. This technique worked technically. A properly placed charge of TNT or Composition C could blast a hole through even the thickest hedger, creating an opening large enough for a Sherman to pass through. But the tactic had fatal flaws. First, it was slow. Engineers had to move forward under fire, approach the hedgerow, place the charges, connect the detonators, retreat to a safe distance, and blow the charge. This process took 10 to 15 minutes under ideal conditions, longer under fire. Second, the explosions announced American intentions to every German within hearing, which in the relatively quiet Norman countryside meant every German within 2 or 3 miles. Enemy machine gunners and mortar teams would train their weapons on the gap before the smoke cleared. Third, American infantry and tanks advancing through these blown breaches were funneled into a single narrow opening that became a pre-targeted killing zone. German gunners did not need to search for targets, they simply fired at the gap and hit whatever came through. Specialized armored vehicles, particularly bulldozer tanks, proved little better. These were standard Sherman tanks fitted with heavy steel bulldozer blades on the front, designed originally for clearing beach obstacles during amphibious landings. In theory, these vehicles could push through or scrape aside the hedgerows, creating passages for following tanks. In practice, they became priority targets for German anti-tank gunners. The bulldozer tanks were slower than standard Shermans, less maneuverable, and highly conspicuous. German observers would identify them immediately and direct anti-tank fire at them, knowing that destroying the bulldozers would deny the Americans their primary means of breaching obstacles. The 75th Armored Division, which had landed in Normandy with 14 bulldozer tanks, lost 11 of them in the first 3 weeks of combat. By early July, American forces had virtually no bulldozer capacity left, and the few surviving vehicles were being hoarded for critical missions rather than routine hedge clearing. By late June 1944, 6 weeks after D-Day, the American advance had slowed to a nightmarish crawl measured not in miles per day, but in yards per hour. The human cost was staggering and unsustainable. Official U.S. Army histories document that 8th Corps advancing through the bowage toward La Haye-Duets and Lay suffered over 10,000 casualties while advancing approximately 7 miles. Some secondary sources have cited figures of 1,000 killed per kilometer for portions of this advance. Though these specific numbers are difficult to verify from official records, what is certain is that American infantry was dying at rates that rivaled or exceeded the worst battles of World War I. The capture of Moncastre, a hill overlooking the Cotentin Peninsula, cost American forces approximately 2,000 casualties in brutal close-quarters fighting. The 1st Infantry Division, which had landed on Omaha Beach on D-Day, lost 75% of its frontline infantry in the first month of combat. Companies that had landed with 150 men were down to 30 or 40 effectives. The 29th Division suffered equally catastrophic losses. This was not mobile warfare. This was not the rapid exploitation that Allied planners had envisioned. This was attritional combat where every field had to be fought for, every hedge assaulted, every few hundred yards of ground purchased with American blood, and America, for all its industrial might and manpower reserves, could not sustain these casualty rates indefinitely. The replacement system was already strained. New soldiers arriving in Normandy were being rushed into combat with minimal training, thrown into veteran units to fill the gaps left by dead and wounded. Morale, which had been high after the successful D-Day landings, was declining rapidly. Soldiers who had survived the beach assault and thought they had faced the worst the war could offer, were being broken by the grinding brutality of hedgerow combat. General Omar Nelson Bradley, commander of the 1st United States Army, faced a crisis that threatened not just his personal reputation, but the entire strategic plan for the invasion of Europe. His forces were exhausted, demoralized, and bleeding irreplaceable infantrymen at rates that could not be sustained. The British and Canadian forces to the east, fighting around the city of Caen, were making equally limited progress against heavy German armor. Field Marshal Montgomery's plan to seize KHN on D-Day had failed completely. The city would not fall until mid-July, more than a month behind schedule. The grand strategy that had guided 2 years of planning, the vision of rapid breakout in mobile warfare across France, was collapsing into the same kind of static trench warfare that had characterized the Western Front in World War I. Bradley's chief of staff, Major General Walter Bedell Smith, who also served as Eisenhower's chief of staff at Supreme Headquarters, described the situation in blunt terms that captured the growing sense of crisis. In the south of Normandy, he wrote in a memorandum to Eisenhower, "Every small field is a fortress, every hedge a German strong point. We are fighting World War I again, but this time the trenches are green and growing. Our advantages in mobility, armor, and firepower are negated by terrain. The Germans are trading space for casualties, and they are winning that exchange." The German defense of Normandy was brilliant in its simplicity and effectiveness. Rather than attempting to hold a continuous front line, which would have required more troops than they had available, German commanders positioned small groups of infantry throughout the bocage, using the natural fortifications to create a defense in depth that was nearly impossible to overcome with conventional tactics. A typical German defensive position in the bocage consisted of 2 or 3 machine gun teams, a mortar crew, and a handful of riflemen, perhaps 20 to 30 soldiers total. These small units would occupy a cluster of 3 or 4 hedgerows, positioning themselves to create interlocking fields of fire in mutually supporting positions. When American forces attacked, the Germans would hold their fire until the Americans were fully committed, emerging from cover and crossing the open fields. Then they would open fire with devastating effect. German machine guns, particularly the MG-42, which was capable of firing 1,200 rounds per minute, could scythe down entire American platoon in seconds. The Americans would take cover, call for artillery support, attempt to identify the German positions. By the time American artillery rounds began falling, the Germans would have already displaced to their alternate positions in the next hedge, leaving the Americans to attack empty positions, while German fire came from a completely different direction. German tactics exploited every advantage the terrain offered. Machine gunners would dig their firing positions deep into the hydrobanks, creating small tunnels or caves that provided overhead protection from artillery and complete concealment from ground observation. The opening of the firing port would be just large enough for the machine gun barrel, perhaps 6 in diameter, camouflaged with cut vegetation that made it invisible from more than a few feet away. A German gunner could sit in complete safety, protected from everything except a direct hit by a large caliber shell and fire on American troops in the open field with virtually no risk to himself. German snipers used the height advantage provided by trees growing on top of the hedge to observe American movements and pick officers and non-commissioned officers. The loss of small unit leaders was particularly devastating to American forces. A rifle company that lost its experienced sergeants and lieutenants in the first few days of combat would be far less effective even if it received replacement officers, because the new leaders did not know the men, did not know who could be trusted in combat, did not have the bonds of mutual trust that held units together under fire. German snipers understood this and deliberately targeted anyone who appeared to be giving orders or carrying maps and radios. The Germans camouflaged their positions with extraordinary care and discipline. They would cut fresh branches every morning to replace wilting camouflage. They would cover the track marks left by their vehicles, sometimes going so far as to try to make flattened grass stand upright again. They dug tunnels under hedgerows to create protected routes for movement between defensive positions, allowing them to displace without being exposed to American fire. Some German units dug elaborate trench systems connecting multiple hedge, creating underground networks that allowed them to move entire squads from position to position without ever being visible to American observers or spotter aircraft. The psychological impact of this combat on American troops was severe and cumulative. Men who had survived the horrors of Omaha Beach, who had faced German machine guns and artillery during the landing, who thought they had endured the worst combat imaginable, found the bocage even more terrifying. On the beach, at least the enemy was visible. You could see the German bunkers. You could identify targets. You knew where the fire was coming from. In the hedge, death came unseen from positions that could not be located. Until they opened fire. Every field was a potential killing ground. Every advance across open ground was a journey into terror, waiting for the moment when German machine guns would open fire and cut you down before you could react. Captain Joseph Ewing, serving with the 175th Infantry Regiment of the 29th Division, described the approach to essay low in terms that captured the suffocating claustrophobia of hedro combat. He later wrote, after the war, "We advanced through a vast maze of natural fortifications miles in depth. Every hedgerow was a possible enemy position. Every field crossing was potentially fatal. We could not see more than one field ahead. We had no way of knowing where the Germans were until they opened fire. The tension, the constant awareness that at any moment machine gun fire might erupt from invisible positions wore men down faster than actual combat. Veterans became hollow-eyed and shaking. New replacements broke under the strain within days. Into this desperate situation where the entire Normandy campaign teetered on the edge of failure, where American casualties mounted by the thousands and no solution seemed possible, came an ordinary soldier with an extraordinary idea. Curtis Grubb III was 29 years old in the summer of 1944, a sergeant serving with the 102nd Cavalry Reconnaissance Squadron, which was part of the 102nd Cavalry Group, operating under the command of 5th Corps. He was nobody special in the vast hierarchy of the American Army. He held no advanced degrees. He had no engineering training. His background was utterly ordinary, the kind of American biography that was repeated millions of times across the armed forces. Coolin was from Cranford, New Jersey, a small town about 15 miles west of New York City. His father worked as a salesman for a liquor distributor. Curtis had attended local public schools, graduating from Cleveland High School in Cranford in 1935. He had worked before the war as a sales promotion assistant for Schenley Industries, the same liquor company that employed his father. When the war came, he had enlisted in the New Jersey National Guard and been mobilized with his unit. He was trained as a tanker and driver. He knew how to maintain and operate a Sherman tank. He knew how to fight in armored combat, but he had no special technical expertise that would suggest he was about to solve a problem that had baffled the best minds in the American military establishment. What Curtis Coolin had was something that could not be taught in any school or acquired through formal training. He had practical American ingenuity, the kind of problem-solving ability that came from growing up during the Great Depression when money was scarce and you learned to fix things yourself, to make do with whatever materials were available, to improvise solutions rather than waiting for someone else to solve your problems. This was a particularly American trait born of a culture that valued individual initiative and practical results over formal credentials and theoretical knowledge. It was the same spirit that had driven American inventors and innovators for generations. From Benjamin Franklin, experimenting with electricity, to the Wright brothers building an airplane in a bicycle shop. In early July 1944, during a brief respite from combat operations, soldiers from Colin's unit gathered in an informal group to discuss the hedro problem. This was not an official meeting or planning session. It was just soldiers talking, sharing frustrations, venting anger about their situation. Tank crews, infantry, and officers all contributed to the conversation. They talked about friends who had been killed or wounded. They talked about tanks that had been destroyed attempting to breach hedgerows. They shared ideas, most of them impractical or impossible, about how to solve the problem. At some point in this discussion, a soldier from Tennessee made a suggestion that sounded to most of the group like a joke or perhaps the ramblings of a man driven half mad by combat stress. Military historian Max Hastings, in his book Overlord D-Day and The Battle for Normandy, published in 1984, identifies the soldier only as a Tennessee hillbilly named Roberts. Hastings provides no first name, no rank, no unit designation, no documentation. Despite extensive research by military historians in the decades since, no primary source has ever been found that verifies this man's identity or even confirms his existence. The account rests entirely on Hastings' single mention, possibly based on oral history. or anecdotal information that cannot be verified. Nevertheless, according to Hastings, the soldier said something like, "Why don't we get some saw teeth and put them on the front of the tank, and cut through these hedges?" Most of the soldiers listening laughed or dismissed the idea immediately. It sounded ridiculous. Saw teeth on a tank like some kind of cartoon monster. But Curtis Coulin, sitting quietly in the group, did not laugh. He heard something in the suggestion that others missed. He recognized that beneath the crude phrasing was a mechanically sound principle. If tanks could not climb over hedge without exposing their vulnerable undersides, and if they could not punch through the solid earth banks by brute force, then perhaps they could cut through them. Use the tank's own weight and power to drive steel blades through the base of the hedge, severing roots and penetrating earth like a plow cutting through tough soil. Kin began thinking about the problem systematically. He envisioned a set of steel prongs or tusks projecting forward from the tank's hull. These prongs would need to be angled slightly downward so that when the tank drove into a hedge or row, they would bite into the earth bank at ground level rather than riding up the face of the obstacle. As the tank continued forward with full engine power, the prongs would cut through the roots and earth while the tank's weight kept it level and prevented the dangerous upward tilt that exposed the belly armor. The severed vegetation and earth would be pushed up and over the tank, but the tank itself would drive straight through the breach at ground level. The concept was simple, elegant, and achievable with available technology, but it required the right materials. The prongs needed to be strong enough to penetrate centuries of packed earth and dense root systems. They needed to be heavy enough to hold their position under stress, but not so heavy that they overloaded the tank suspension or reduced its mobility. They needed to be made from high-quality steel that would not bend or break under the enormous forces involved in cutting through a hedgerow. Where could such materials be found in Normandy in July 1944? The answer was literally lying on the beaches where the invasion had taken place 6 weeks earlier. Before D-Day, German engineers had installed thousands upon thousands of obstacles along the Normandy coast, creating a barrier system designed to destroy Allied landing craft before they could reach shore. Among the most common obstacles were devices called Czech hedgehogs, named for their resemblance to the anti-tank obstacles the Czech army had developed before the war. Each hedgehog was constructed from 3 steel I-beams, industrial-grade structural steel about 6 feet long, welded together at angles to form a 6-pointed obstacle that looked somewhat like a giant jack from a children's game. These hedgehogs were supposed to rip open the hulls of landing craft or provide anchor points for mines. In the event, the invasion had bypassed or destroyed most of them. Thousands of Czech hedgehogs now lay scattered along the invasion beaches. Having failed to stop the Allied assault, they had been pushed aside by the landing forces, blown up by combat engineers, or simply bypassed. The steel beams, still intact and of excellent quality, were being collected in salvage yards behind the beaches, waiting to be shipped back to England for recycling. Here was exactly what Cullen needed: high-quality structural steel already cut to convenient lengths available in unlimited quantities. All he needed was permission to experiment and access to welding equipment. Getting approval from his immediate superiors proved surprisingly easy. Officers at every level of the American Army in Normandy were desperate for any solution to the hedgerow problem. When Curtis Coulin approached his company commander with rough sketches and an explanation of his concept, including where he planned to source materials, the captain gave immediate approval. Within 48 hours, Kin had been given access to a Sherman tank for experiments, welding equipment from the unit maintenance section, and authorization to organize a work party to retrieve steel beams from a salvage yard near Omaha Beach. The prototype took 3 days to construct in early July 1944. Colleen and his work party selected 4 sections of steel I-beam from the salvage yard, each approximately 5 feet long and weighing about 100 pounds. They used cutting torches to bevel the forward ends of the beams, creating angled cutting edges that would bite into earth and roots more effectively than blunt ends. They welded a horizontal crossbar to hold the 4 prongs in position, spacing them evenly across the width of the tank's front hull. Then they welded the entire assembly, prongs and crossbar, together to the lower front armor plate of the Sherman, positioning it so the prongs projected forward and angled slightly downward. The result was crude but functional. Four steel tusks projecting forward from the tank's hull, angled downward at perhaps 10 degrees from horizontal. Ready to be driven into a hedgerow, the assembly added about 400 pounds to the tank's weight, not enough to significantly affect performance, but enough to be noticeable. The prongs extended about 4 feet in front of the tank's normal profile, which meant drivers would need to be careful in close quarters maneuvers. But if the device worked, these minor inconveniences would be more than justified. The first test was conducted on July 11, 1944 in a field near the town of Iceni Sumra, several miles inland from Omaha Beach. A small group of perhaps 20 soldiers gathered to watch, mostly tankers and officers from Cullen's unit. Most of them expected another failure. They had seen too many proposed solutions to the hydro problem, all of which had failed in one way or another. A tank with steel prongs welded to the front seemed unlikely to succeed, where explosives and bulldozers had failed. But they were willing to watch, if only to be able to say they had been there when yet another crazy idea fell apart. The test hydro was selected carefully. It needed to be representative of typical Norman bocage, not an unusually small or weak example that might give false results. The hydro they chose was about 4 feet high at the earthen base, topped with 15 feet of mature vegetation, including oak trees with trunks 4 or 5 in diameter. This was an average hedgerow, the kind American tankers encountered dozens of times every day. If Cullen's device could breach this obstacle, it could breach most of the hedgerows in Normandy. The Sherman tank backed up to give itself room to build speed. The driver, a corporal from Pennsylvania, whose name has not been preserved in historical records, was understandably nervous. If the device failed, if the tank bellied up on the hydro, as so many tanks had before, he and his crew might be the next casualties of the bowage. But he trusted Sergeant Coulin, who had explained the theory carefully and seemed confident it would work. The driver shifted into gear, advanced the throttle, and aimed directly at the hedger. 5 miles per hour 810. The tank hit the hedger with the prongs leading. There was a sound like heavy canvas tearing, a deep ripping noise as steel cut through earth and roots. The prongs bit into the earthen bank and penetrated deep. For a moment, it seemed the tank might stall, might be stopped by the resistance of the obstacle. Then the engine roar increased. The driver gave it full throttle. The tank's treads gripped the ground and pushed forward. Earth fountained up and over the tank's hull, blown upward by the force of the breach. Branches snapped, tree trunks splintered, vegetation showered down on the turret and rear deck, and then less than 5 seconds after impact, the Sherman burst through to the other side of the hedge, trailing broken branches and torn roots, but otherwise completely undamaged. The tank had not climbed the obstacle. It had cut through at ground level, exactly as Colleen had predicted. The watching soldiers erupted in cheers and shouts. Some of them were crying, not from sadness, but from relief and hope. For 6 weeks they had watched friends die in futile attempts to breach these obstacles. For 6 weeks they had felt helpless against terrain that seemed unconquerable. Now suddenly impossibly a simple device made from scrap metal had solved the problem. The tankers surrounded Colleen, shaking his hand, pounding his back, thanking him with a fervor that embarrassed the modest sergeant. Officers who had witnessed the test were already calculating implications. If this worked once, it could work again. If one tank could be modified, all tanks could be modified. If the device was as simple and quick to manufacture as it appeared, then perhaps the entire American armor force could be equipped before the planned offensive. But a single successful test, however dramatic, was not enough to transform the course of a military campaign. The device needed to prove itself in repeated trials under various conditions. More tests were conducted over the next 2 days. Different hedgerows, different angles of approach, different speeds. Every test succeeded. The device worked reliably, predictably, safely. Tank crews quickly learned the optimal technique. Approach at 10 to 12 miles per hour. Aim directly at the hedger, not at an angle. Give full throttle at impact. The tank would shudder as the prongs bit into earth, but it would drive straight through without climbing or exposing its belly. Breaching time averaged 5 to 8 seconds from impact to emergence on the far side. Word of Cullen's invention spread rapidly through the 2nd Armored Division and beyond. Within 3 days of the first successful test, Major General Edward Brooks, commanding the 2nd Armored Division, had seen reports and requested a formal demonstration. Brooks was a competent, aggressive commander who understood armor tactics and recognized a breakthrough when he saw one. He immediately grasped the significance of Cullen's device and understood that it needed to be demonstrated to the one man whose approval and support could authorize mass production and force-wide implementation. On July 13, General Brooks sent a message to 1st Army headquarters requesting that Lieutenant General Omar Bradley visit the 2nd Armored Division area for a demonstration of a new hedger breaching device. Bradley, buried under reports and complaints about the stalled offensive, was initially skeptical. He had seen proposed solutions before, all of which had failed. But Brooks insisted this was different, and Bradley trusted his division commanders. He agreed to visit the following day, July 14, 1944, the demonstration that opened this narrative. Bradley arrived with his entourage, including Major General Leonard Garrow of 5th Corps and several ordnance specialists. 2 tanks had been prepared for demonstration, a light M5A1 Stuart tank and a medium Sherman, both equipped with Cullen's device. The hedro selected for the demonstration was carefully chosen to be representative of typical bocage terrain, 5 feet earthen bank topped with thick brush and mature trees, the kind of obstacle that had stopped American advances for 6 weeks. Bradley and his officers took up positions where they could observe clearly without being in danger if something went wrong. The light tank performed first, backing up to gain speed, then accelerating directly at the hedgerow. The impact, the sound of tearing earth and breaking roots, the fountain of dirt exploding upward, and then the tank bursting through in less than 5 seconds. Before anyone could react, the Sherman demonstrated the same capability with even more dramatic effect. Its greater weight and power drove through the obstacle like it was soft clay rather than centuries-old earthen wall reinforced with tree roots. Bradley stood silent for a moment, his mind racing through implications. 6 weeks of stalemate, thousands of casualties, an offensive about to be launched that might fail if tanks could not maneuver through the bowage. And here, demonstrated twice in the space of 2 minutes, was the solution. Simple, reliable, achievable with available materials. He turned to his ordnance chief and issued the orders that would change everything. The conversation that followed the demonstration lasted less than 10 minutes, but set in motion a manufacturing effort unprecedented in its speed and scale. Bradley wanted these devices on as many tanks as possible before Operation Cobra launched. The offensive was scheduled to begin in 11 days on July 25. That meant 11 days to manufacture hundreds of devices, transport them to units scattered across Normandy, and weld them onto tanks. It meant round-clock production. It meant mobilizing every ordnance unit, every maintenance depot, every welder in the American sector. It meant improvising a mass production system for a device that had been invented less than a week earlier. Lieutenant Colonel John Madoris, 1st Army Ordnance Officer, was given personal responsibility for the manufacturing program. He was a West Point graduate, class of 1930, a professional officer with extensive experience in logistics and material. He understood immediately that this was not a routine production job. This was an emergency crash program that might determine the outcome of the entire Normandy campaign. Madoris returned to his headquarters and within hours had issued orders that would set in motion the most rapid military production program of the war. Every ordnance company, maintenance battalion, and repair depot in the American sector received orders on July 14 to begin immediate production of hedro cutting devices. Specifications were transmitted by telephone and radio. For steel prongs approximately 5 feet long made from German beach obstacle steel. Beveled cutting edges on the forward ends. Crossbar to hold prongs in position. Entire assembly welded to lower front hull of tank. Simple enough that any competent welder could fabricate it. Complex enough that it required skill and care to ensure the welds would hold under combat stress. The raw material was abundant. Salvage yards behind the beaches contained thousands of tons of steel from destroyed German obstacles. Trucks began hauling steel beams to ordnance units across Normandy. The beams arrived in bundles, still covered with rust and barnacles from their time underwater, some still showing damage from explosives or shellfire. Ordnance troops would sort through the beams, selecting those that were straight and undamaged, rejecting any that showed cracks or severe corrosion. The selected beams would be cut to length using acetylene torches, beveled on the ends, and set aside for welding. The welding work was brutal. Summer heat in Normandy in July 1944 reached into the 80s and 90s Fahrenheit. Welders worked in heavy leather protective gear, wearing face shields and gloves, manipulating steel beams that weighed over 100 pounds each. The work was done outdoors or in canvas-sheltered areas. Because there was no time to set up proper workshops, each device required multiple hours of welding. The four prongs had to be welded to the crossbar. The crossbar had to be welded to the tank's hull. Every weld had to be strong enough to withstand the enormous forces generated when the tank drove into a hedgerow at full speed. A weak weld could fail at the moment of impact, potentially causing the tank to belly up on the obstacle, exactly as unmodified tanks did. The ordnance units worked in shifts 24 hours a day. Welders worked 6-hour shifts, then rested while other crews took over. Acetylene tanks and welding rods had to be trucked in constantly to keep the work going. When one ordnance company ran low on materials, trucks would be dispatched to transfer supplies from units that had excess. The entire system operated with the kind of flexible improvisation that characterized American military logistics at its best. There were no detailed plans, no carefully calculated production schedules. There was only the urgent need to produce as many devices as possible before Operation Cobra launched. Tank crews from combat units would drive their vehicles to the nearest ordnance facility, wait while the device was fabricated and installed, then drive back to their units. Some crews waited 6 or 8 hours. Others waited overnight, but they waited because they knew the device might save their lives. Tankers who had lost friends to panzer fire when tanks bellied up on hedge understood that Kin's device could prevent those deaths. They were willing to wait as long as necessary to get their tanks modified. The modified tanks began appearing in combat units in mid-July. At first, there were just a handful per battalion. Crews with modified tanks would volunteer for the most dangerous missions, testing the devices under actual combat conditions. The reports that came back were uniformly positive. The devices worked exactly as demonstrated. Tanks could breach hedge in seconds without exposing their vulnerable undersides. Tank commanders could choose their own routes through the bouquet carriage rather than being forced to follow roads or search for gaps that might be covered by German fire. The tactical flexibility was transformative. By July 20, 5 days before Operation Cobra was scheduled to begin, approximately 300 tanks in 1st Army had been fitted with Colleen's device. This represented about 15% of American armor in the theater. It was not enough. Bradley wanted more. Medeiros pushed production harder. More ordnance units were diverted from other tasks. More welders were pulled from maintenance work and set to manufacturing hydrocutters. The pace became frantic, desperate, driven by the knowledge that Operation Cobra was approaching, and every tank without a device was a tank that might be stopped by the bouquet. By July 24, the day before Operation Cobra launched, approximately 500 devices had been manufactured and installed on American tanks. This represented nearly 60% of the Sherman medium tanks, Stuart light tanks, and M10 tank destroyers that would participate in the offensive. It was not 100%. There had not been enough time, but it was enough to give American armor the mobility it needed, enough to restore tactical flexibility, enough to break the stalemate. The tanks themselves looked fearsome with their new equipment. The 4 steel prongs projecting from each hull gave the Shermans an aggressive, almost predatory appearance. Soldiers began calling them rhino tanks, drawing the obvious comparison to the horned animals of Africa. Others called them rhinoceros tanks. The names stuck. Within days, everyone in the American Army knew what a rhino tank was. The British forces, observing the American modification and recognizing its value, quickly developed in their own version. British ordnance units called their devices prongs and began manufacturing them from German beach obstacles, just as the Americans had done. By August, British prongs were being fitted to Sherman tanks in the British sector, though British production never reached the scale of the American effort. The Germans encountering Rhino tanks in combat for the first time during Operation Cobra had no official designation for them. German after-action reports and prisoner interrogations refer to them variously as American Hedger tanks, tanks with steel horns, or simply the modified Shermans. What is clear from German accounts is that the appearance of these devices was a nasty surprise. German defensive tactics in the Beige had relied heavily on the assumption that American tanks could not maneuver effectively through Hydro country. When that assumption proved false, German defenses collapsed far more rapidly than they might have otherwise. The final days before Operation Cobra were filled with feverish preparation. Infantry units rehearsed assault techniques. Artillery officers registered their guns on pre-planned targets. Air Force liaison officers coordinated with ground units to ensure close air support would be available. And throughout the American, hundreds of Sherman tanks with newly welded steel prongs conducted final tests, training crews in the techniques of Hedger breaching, ensuring that when the offensive began, armor could exploit any breakthrough achieved by infantry and air power. July 25, 1944. 0940 hours. The sky over Normandy filled with the sound of approaching aircraft. More than 1,500 B-17 Flying Fortress and B-24 Liberator heavy bombers flying in formations so large they darkened the sky approached their targets in a rectangular area northwest of St. Lo. The bombers had taken off from bases in England hours earlier, climbing to altitude over the English Channel, forming up into their massive formations, then flying south across the invasion beaches toward their assigned target zones. The target area for the carpet bombing was a rectangle approximately 5 miles long and 1.5 mi wide between the towns of Monter and Hebra. This was the sector held by German forces directly in the path of the planned American offensive. The bombing was intended to obliterate German defenses, destroy command and control networks, kill or stun German soldiers, and create chaos that would allow American ground forces to penetrate deep into German rear areas before effective resistance could be organized. The bombardment began at exactly 0940. The first bomber wings released their loads from altitude. High explosive bombs and fragmentation bombs fell in a deadly rain. The effect on the ground was apocalyptic. Bombs weighing 500 pounds, 1,000 pounds, even 2,000 pounds detonated in rapid succession. The earth heaved and shook. Trees were blown to splinters. Hydros were obliterated. Buildings collapsed. German soldiers caught in the open or in inadequate shelters were killed instantly by blast or shredded by flying fragments. Those who survived the initial explosions were left stunned, deafened, unable to think or function. The bombing continued for nearly 1 hour. Wave after wave of heavy bombers passed over the target area, each plane releasing its bombs, then turning for the flight back to England. Following the heavy bombers came approximately 1,000 medium bombers and fighter bombers, carrying incendiary bombs and additional high explosives. By the time the last aircraft departed, approximately 3,300 tons of high explosive bombs and 60,000 incendiary bombs had been dropped on the target area. The bombardment covered 12 square km with approximately 5,000 bombs per square kilometer. The landscape was transformed into a Peruvian 25 moonscape of overlapping craters, splintered trees, and burning debris. But the precision that bombarders had hoped for proved impossible to achieve. The target area was close to American front lines, separated in some places by only a few hundred yards. Thick clouds obscured visibility. Bomb aiming was done by dead reckoning and radar, both imprecise methods under the best circumstances. Some bombs fell short of the target zone, landing instead on American positions. The results were tragic. 111 American soldiers were killed and nearly 500 wounded by bombs from their own aircraft. Among the dead was Lieutenant General Leslie James McNair, who had been observing the bombardment from a forward position with troops of the 30th Infantry Division. McNair was the highest-ranking American officer killed in combat in the European theater during World War II. He held the rank of lieutenant general at the time of his death, though he would receive a posthumous promotion to full general. His death was a severe blow to American morale and a stark reminder of the risks of close air support. The friendly fire casualties on July 25 added to casualties from a similar incident the previous day when initial bombing runs had been aborted due to weather, but not before some aircraft had already released their bombs, killing and wounding over 150 Americans. The total friendly fire casualties from the Operation Cobra bombardment exceeded 800 killed and wounded. Despite these tragic losses, the bombardment achieved its primary objective. German defenses in the target area were effectively destroyed. The Panzer Division, one of the elite German armored formations defending the sector, was reduced to a remnant of its former strength. Its commander, General Fritz Bayerlein, later described the scene in terms that captured the sheer overwhelming violence of the bombardment. "I observed a pea of dust with fountains of earth spewing high in the air. My front lines looked like a landscape on the moon, and at least 70% of my troops were out of action, dead, wounded, crazed, or numb. Approximately 1,000 German soldiers were killed in the bombardment. Dozens of command posts were destroyed, obliterating the command and control network that coordinated German defenses. Communications were cut. Telephone lines were severed by explosions. Radio antennas were knocked down. Officers attempting to give orders found themselves unable to communicate with subordinate units. Survivors of the bombardment emerged from their shelters stunned, deafened, many of them suffering from concussion and shock. German defensive positions that had withstood weeks of American attacks were obliterated in less than an hour. Into this chaos, American ground forces advanced. The 7th Corps, commanded by Major General J. Lorton Collins, formed the main thrust of Operation Cobra. Collins was one of the most aggressive and competent corps commanders in the American Army. A man who understood the importance of maintaining momentum and exploiting success. His nickname was Lightning Joe, earned during fighting in the Pacific, and it reflected his tactical philosophy of speed and violence of action. 3 infantry divisions formed the assault force for 7th Corps, the 4th Infantry Division on the right flank, the 9th Infantry Division in the center, the 30th Infantry Division on the left. These divisions had been fighting in Normandy since D-Day. They were experienced, battle-hardened, and grimly determined. Their mission was to attack south from positions near Sanlo, penetrate German defenses shattered by the bombardment, and open a corridor through which American armor could exploit. Behind the infantry divisions waited 2 armored divisions. The 2nd Armored Division, the Hell on Wheels Division, was commanded by Major General Edward Brooks. The 3rd Armored Division, the Spearhead Division, was commanded by Major General Leroy Watson. These divisions contained the bulk of American armor that would participate in Operation Cobra, and a substantial portion of their Sherman tanks, approximately 60%, were now equipped with Curtis Coulin's Hedro cutting devices. The infantry assault began in the early afternoon of July 25, several hours after the bombing ended. American troops advanced through the devastated landscape, moving cautiously at first, expecting German resistance to materialize at any moment, but the resistance was disorganized and weak. German soldiers who had survived the bombardment were in no condition to mount effective defense. Many were still stunned, sitting in bomb craters, unable to comprehend what had happened. Others attempted to resist, but found their weapons buried under rubble or their ammunition expended. Command and control had broken down completely. German officers attempting to organize defense found themselves unable to communicate with higher headquarters or coordinate with adjacent units. The initial advance on July 25 penetrated approximately 1 mile beyond the start line. This was slower than hoped, evidence that even the massive bombardment had not completely eliminated German resistance. Hedros, even when damaged by bombing, still provided some defensive value. American infantry still had to clear German positions field by field in brutal close quarters combat. But the resistance was not the organized, coordinated defense that had stopped previous American attacks. This was the fighting of scattered survivors, individual acts of courage or desperation rather than systematic defense in depth. Major General Collins, monitoring the advance from his forward command post, recognized something that others might have missed. The German resistance, though still deadly, was not coherent. There was no defensive plan being executed, no coordinated counterattacks, no unsystematic attempt to establish new defensive positions. The German command structure had been destroyed by the bombardment. Units were fighting in isolation, without support, without direction. The German front line was not bending under American pressure. It was breaking. Late in the afternoon of July 25, Collins made the bold decision that would transform Operation Cobra from a limited offensive into a breakthrough that changed the entire Normandy campaign. He ordered his 2 armored divisions to begin their exploitation immediately ahead of the original schedule. The plan had called for infantry to open a wide corridor before armor advanced, but Collins saw that waiting might allow the Germans time to recover, to establish new defensive positions, to bring up reinforcements. He decided to commit his armor while the Germans were still reeling from the bombardment, gambling that American tanks could exploit the chaos before German defenses could solidify. The armored exploitation began. At dawn on July 26, Combat Command A of the 2nd Armored Division led by Brigadier General Maurice Rose drove south from the St. Lo area with orders to advance as far and as fast as possible. Rose was an aggressive commander who understood armored warfare and knew how to exploit success. His column consisted of Sherman tanks, tank destroyers, armored infantry and half-tracks, and self-propelled artillery. And crucially, the majority of his tanks were equipped with Collins's hydro-cutting devices. For the first time since D-Day, American armor operated with true mobility and freedom of maneuver in the Norman bouquet carriage. The Rhino tanks crashed through hedger after hydro, choosing their own routes, avoiding German strong points, exploiting gaps in the disintegrated German defense. Tank commanders no longer needed to follow roads where German anti-tank guns might be positioned. They no longer needed to search for gaps in hedge that might be covered by German fire. They simply drove cross-country, breaching obstacles at will, maintaining momentum, preventing Germans from establishing new defensive positions. The psychological impact on German forces was catastrophic. For 6 weeks, German defenders had relied on the bowage as their primary defensive advantage. They had used the hedge to channel American attacks into predetermined killing zones. They had positioned anti-tank weapons to cover the few routes through which American armor could advance. Now, suddenly, impossibly, American tanks were appearing from unexpected directions, breaking through hedgerows that Germans had assumed were impossible barriers. The entire German defensive system, carefully constructed over weeks of combat, was rendered obsolete in a single day. German attempts at counterattack proved futile. Small groups of German infantry attempting to block American advances found themselves bypassed and isolated as American tanks drove through hedge on either side of their positions. German anti-tank guns, carefully positioned to cover roads and known passages, found their fields of fire blocked by hedgerows, while American tanks emerged from directions the Germans had not anticipated. German officers attempting to coordinate defense found themselves unable to predict where American armor would appear next. By midday on July 26, lead elements of the 2nd Armored Division had advanced 6 miles beyond the start line, 6 miles in half a day. This was farther than the entire First Army had managed to advance in the previous 2 weeks of grinding attritional combat. The contrast was stark and dramatic. The town of Marini, a significant road junction 6 kilometers south of the start line, fell to the 1st Infantry Division supported by the 3rd Armored Division. German prisoners, many of them reinforcements who had just arrived from training battalions in Germany, surrendered in such numbers that American units simply directed them to walk to the rear without guards. There were not enough military police to process them all. A senior non-commissioned officer in a German Medical unit, identified in captured documents only by his last name, Clean, wrote in his diary on the evening of July 26. Today we understood that everything is lost. The Americans have broken through. Their tanks are everywhere. They come from directions we thought impossible. Our defensive positions that held for weeks are suddenly worthless. The men are talking among themselves in ways that would have been unthinkable a week ago. They speak of survival, not victory. They speak of escape, not defense. Morale has collapsed overnight. July 27, the American advance accelerated. The 30th Infantry Division, which had suffered the worst of the friendly fire casualties on July 25, reported in words that would become famous, "This thing has busted wide open." The 3rd Armored Division reached the area around Coutances, a critical road junction, approximately 15 miles behind what had been the German front line just 2 days earlier. German forces attempting to withdraw south to avoid encirclement found their routes blocked by American armor that had already penetrated deep into their rear areas. Entire German units were cut off, surrounded, destroyed, or forced to surrender. The breakthrough, achieved by July 28, exceeded even Bradley's optimistic projections. American forces had penetrated more than 20 miles beyond the start line in just 3 days. The German 7th Army, which had fought the Americans to a standstill for 6 weeks in the Bocage, was in full retreat, its units scattered and disorganized, its command structure shattered, its ability to conduct coordinated defense destroyed. The Bocage, the nightmare terrain that had seemed to make sustained offensive operations impossible, was now behind American lines. Ahead lay the relatively open country of central France, where American mobility and firepower advantages could be employed without restriction. Post-battle analysis conducted by American intelligence officers in the weeks following Operation Cobra revealed the decisive role of the Rhino tanks. Staff officers examined after-action reports, interviewed unit commanders, and compiled statistics on how hedgerows had been breached during the offensive. The conclusion was clear and dramatic. Approximately 70% of successful hedgerow breaches during Operation Cobra were accomplished by tanks equipped with Cullen's devices. The remaining 30% required engineer support with explosives, bulldozers, or manual labor, all of which were significantly slower and more vulnerable to German defensive fire. Tank crews reported that the Cullen devices allowed them to breach typical Norman hedge in less than 10 seconds from initial impact to emergence. On the far side, this speed was absolutely critical to maintaining momentum and preventing German forces from repositioning to counter each breach. Previous methods of breaching hedgerows had required anywhere from 10 minutes to half an hour, allowing Germans to prepare defensive fire against any breach. The speed advantage provided by the Rhino tanks gave American forces the tactical surprise and tempo that made rapid exploitation possible. American tanks equipped with Cullen devices also suffered significantly fewer casualties than unmodified tanks operating in the same terrain. Ordnance officers analyzing loss rates found that Rhino tanks experienced approximately 40% fewer tank kills than standard tanks in Bocage terrain. The primary reason was simple: modified tanks did not expose their vulnerable belly armor when crossing hedgerows, eliminating the single most common cause of tank losses in the Bocage. German panzer teams that had devastated American armor in June and early July found their tactics suddenly ineffective against Rhino tanks that drove through hedge at ground level. The strategic impact of Operation Cobra was immediate, dramatic, and far-reaching. By July 31, just 6 days after the offensive began, the 8th Corps had captured the town of Avanches, described by military historians as the gateway to Brittany and southern Normandy. The capture of Avanches opened routes south into Brittany and east towards central France. The entire Normandy front, which had been static for 6 weeks, suddenly collapsed. German forces that had fought so effectively in defensive positions found themselves unable to conduct mobile defense in open terrain against American armor that could now maneuver freely. American forces poured through the gap at Avranches like water through a broken dam. On August 1, 1944, the Third United States Army was officially activated under the command of Lieutenant General George Smith Patton Jr. Patton was one of the most aggressive and controversial American commanders, a man who understood armored warfare and believed in rapid exploitation and deep penetration. Third Army's mission was to exploit the breakthrough achieved by First Army, racing south into Brittany to capture the ports and east toward the Seine River to encircle German forces still fighting in Normandy. Patton's Third Army advanced with a speed that astonished both American and German commanders. Armored columns raced across France, sometimes covering 50 miles in a single day, bypassing German strong points, leaving isolated German units to be mopped up by following infantry. The war of attrition that had characterized Normandy from D-Day to late July was replaced almost overnight by a war of maneuver where American advantages in mobility, logistics, and air power could be fully exploited. The liberation of Paris followed on August 25, just 1 month after Operation Cobra began. General Charles de Gaulle led French forces into the city as German resistance collapsed. The encirclement and destruction of German forces in the Files Pocket completed in mid-August trapped between 50,000 and 100,000 German soldiers and destroyed the combat effectiveness of entire divisions. Tanks, artillery, and vehicles that escaped the pocket itself were destroyed by Allied fighter bombers as they retreated toward the Seine. The Wehrmacht in France never recovered from this catastrophic defeat. For Curtis Cullen, recognition came in the form of military awards and media attention, though both were somewhat bittersweet. General Omar Bradley personally recommended Cullen for the Legion of Merit, a decoration typically reserved for officers who had distinguished themselves through exceptionally meritorious conduct in the performance of outstanding services. The citation accompanying the award praised Kin's contribution to the success of Operation Cobra and noted that his invention had saved countless American lives by restoring tactical mobility to American armored forces at a critical moment in the campaign. Newspapers in the United States picked up the story and transformed Cullen into a minor celebrity. The Cranford Citizen and Chronicle, his hometown newspaper, published a feature article on September 7, 1944, describing how a local sergeant had invented a device that revolutionized warfare in Normandy and contributed to the Allied breakthrough. The article included interviews with Colleen's parents, who still lived in Cranford, and descriptions of his pre-war life as an ordinary young man working in the liquor industry. The story fit perfectly into the American narrative of citizen soldiers using practical ingenuity to overcome obstacles that defeated trained experts. But Curtis Cullen himself, demonstrating the modesty that characterized him throughout his life, refused to take full credit for the invention. In interviews with his commanders and later with journalists, he repeatedly attempted to give credit to the Tennessee soldier whose offhand suggestion had sparked the initial idea. Cullen insisted that this man, whoever he was, deserved recognition for the concept, even though Cullen had been the one to develop the actual working device, build the prototype, test it, and demonstrate it to Bradley. This attempt at sharing credit, though honorable, was largely forgotten in the publicity surrounding the invention and Cullen's rising fame. The Tennessee soldier, identified by historian Max Hastings only as Roberts from Tennessee, vanished from the historical record. Despite extensive research by military historians in the decades since, no primary source documentation has ever been found that verifies this man's identity, rank, or unit. The entire account rests on Hastings's single mention in his book, possibly based on oral history or anecdotal information that cannot be independently confirmed. The man may have existed with a different name, or the account may be a conflation of multiple conversations, or Hastings may have been working from imperfect memory or second-hand sources. The mystery remains unsolved. 4 months after his moment of triumph at the July 14 demonstration, Curtis Cullen's war ended in Germany's Hergon Forest. November 1944. The 102nd Cavalry Group, along with numerous other American units, fought in the Heron Forest, a heavily wooded area along the German-Belgian border southeast of Aachen. The Battle of Hergon Forest was one of the longest and most brutal battles fought by American forces in Europe, a grinding attritional struggle in terrain that resembled the bowage in its difficulty, but with the added horrors of winter weather and fanatical German resistance on their own soil. During combat operations on November 2, 1944, Sergeant Curtis Cullen was moving through the forest when he stepped on a German anti-personnel mine. The explosion shattered his left leg. He fell and in falling detonated a second mine that severely wounded his right thigh. He was evacuated under fire by his comrades, transported to a field hospital, then evacuated through the medical chain to rear area facilities in Belgium and eventually England. Surgeons saved his life, but could not save his leg. The shattered limb was amputated. His combat service was over. Curtis Cullen returned to the United States in 1945 for continued recovery and rehabilitation. He married Bernice Enright in 1945 in Cranford, though the marriage would later end in divorce in the early 1950s. He settled in New York City and, like millions of other veterans, returned to civilian life and attempted to build a normal existence after years of war. He took a job as a salesman for Schenley Industries, the same liquor distributor that had employed his father for years and for which Curtis himself had worked before the war. He raised a family. He lived quietly. He rarely spoke about his wartime experiences or his contribution to the Allied victory in France. On January 10, 1961, just 10 days before leaving office, outgoing President Dwight David Eisenhower delivered remarks upon receiving the Hoover Medal Award from the American Society of Mechanical Engineers at the Statler Hilton Hotel in Washington, District of Columbia. In that speech, delivered before an audience of engineers and business leaders, Eisenhower chose to tell Curtis Cullen's story as an example of American innovation and the critical importance of creating organizational systems that allow good ideas to rise from any level regardless of rank or formal the credentials. Eisenhower, who had been Supreme Commander of Allied forces in Europe and had overseen the Normandy invasion from the highest strategic level, said there was a little sergeant. His name was Kin, and he had an idea, and his idea was that we could fasten knives, great big steel knives, in front of these tanks, and as they came along, they would cut off these banks right at ground level. They would go through on the level keel, would carry with themselves a little bit of camouflage for a while, and this idea was brought to the captain, to the major, to the colonel, and it got high enough that somebody did something about it, and that was General Bradley, and he did it very quickly. Eisenhower continued, emphasizing the broader lesson. The biggest and happiest group, I suppose, in all the Allied armies that night were those that knew that this thing worked. It saved thousands of lives. He went on to note that Cullen had later lost a leg, but was still healthy and working as a salesman in New York the last time Eisenhower had seen him. The speech was Eisenhower's way of emphasizing that good ideas can come from anywhere in an organization, that leaders must create systems that allow innovation from the bottom up, and that sometimes the most important contributions come not from generals or experts, but from ordinary people who see problems clearly and solve them practically. Curtis Grub Cullen III died on November 20, 1963. In Greenwich Village, Manhattan, New York. He was 48 years old. The exact causes of death are not recorded in surviving historical documents. He was interred with full military honors at Fairview Cemetery in Westfield, New Jersey, near his hometown of Cranford. He was laid to rest as a veteran of the 102nd Cavalry Group and a recipient of the Legion of Merit, Purple Heart, and other commendations. This was the man whose improvised invention had shattered the Normandy Stalemate and played a decisive role in the Allied victory in France. A commemorative plaque was later installed on a boulder outside the Cranford Municipal Building in New Jersey, honoring both his service and his contribution to the Allied campaign. The hedgerow cutter he devised remained in use by American armored units throughout the remainder of the European conflict, though its significance decreased as Allied forces left the hedgerow country of Normandy and entered the more open terrain of central and eastern France. The devices were not removed from tanks after departing Normandy. Many Rhino-equipped tanks participated in the liberation of Paris, the rapid advance across France, and even the winter campaigns in Germany. However, the dense hedgerows that had made the device essential were unique to Normandy, and in other theaters, the steel prongs were more cumbersome than advantageous. British forces, observing the American Rhino tanks in Normandy and recognizing their utility, quickly developed their own version of the hedgerow cutter. British ordnance units called their adaptation prongs and began producing them in mid-July from German beach obstacles, using the same source materials discovered by the Americans. By August 1944, British factories had produced 600 Mark I prongs, which were shipped to Normandy and fitted to Sherman V tanks in British and Canadian units. Production continued through autumn, with 1,000 M2 prongs and 500 Mark III prongs made for various tank types, including Sherman M10 tank destroyers and Cromwell tanks. Even some Churchill tanks, which normally did not require hedgerow cutters due to their hull design, were equipped with prongs. The story of Curtis Cullen and the hedgerow cutter has become a lasting part of American military heritage and is regularly taught at service academies, staff colleges, and professional military education courses as a case study in battlefield innovation and organizational adaptability. It illustrates several enduring lessons. First, it highlights the critical importance of fostering a culture that encourages innovation at all levels of command. Curtis Cullen was a sergeant, an enlisted man, not an officer or formally trained engineer. Yet his immediate superiors listened to his proposal, provided resources for testing, and forwarded the successful demonstration up the chain of command. This openness to ideas regardless of rank exemplified the best of the American military ethos. Second, the story underscores the value of practical ingenuity and hands-on problem-solving over formal training and theoretical knowledge when facing unexpected challenges. The hedgerows were a tactical problem that neither Allied intelligence nor planning staffs had anticipated. No doctrine existed for fighting in such terrain, and no equipment had been designed specifically for hedgerow operations. The solution came not from high-level planning or research laboratories, but from a soldier in the field who assessed the problem, evaluated available materials, and devised a practical solution. Third, it demonstrates the importance of rapid implementation once a promising solution is identified. Bradley's decision to authorize immediate mass production of the Cullen device, mobilizing every ordnance unit in the American sector for round-the-clock manufacturing, transformed a single sergeant's improvisation into a force-wide capability in under 2 weeks. Such rapid action was only possible because American military logistics and industrial infrastructure were sufficiently flexible to support fast improvisation. In a more rigid system, the device might have gone through prolonged evaluation, engineering board review, stateside production, and eventual deployment months later, long after the crucial window had passed. The hedgerow problem itself has become a case study in military education on how even excellent intelligence can fail to identify critical tactical challenges. Allied intelligence officers possessed excellent aerial photography of Normandy in the weeks and months before D-Day, clearly showing the hedgerow landscape with thousands of enclosed fields. British and American photo interpreters could count the hedgerows and measure their dimensions. Yet apparently no one in the intelligence chain or planning staff considered how tanks would navigate this terrain or what effect these ancient field boundaries might have on operations. This lapse of imagination nearly caused the Normandy invasion to stall into a prolonged stalemate. American soldiers confronting the hedgerows in June and July 1944 faced some of the most grueling and demoralizing combat of the entire European campaign. The terrain nullified many advantages in firepower, mobility, and air support. Casualty rates rivaled or exceeded the worst battles of World War I. Soldiers watched comrades fall in assaults that seemed futile, attacking positions that appeared impossible to overcome. Weeks of grinding attritional combat offered no clear end in sight, no breakthrough, no victory, just endless fields, hedges, and German machine guns. Yet the troops persevered through courage, discipline, adaptation, and ultimately, innovation. When one of their own devised a solution to the central tactical challenge, they embraced it eagerly and used it to break the stalemate that had held them for 6 weeks. The breakout from Normandy in late July and August 1944 transformed the Western European theater. From late July to the end of 1944, Allied forces advanced from the Norman coast to the German border, liberating France, Belgium, Luxembourg, and parts of the Netherlands. German units that had held the Allies in check in the hedgerows never recovered from the subsequent defeats during the retreat across France. The Wehrmacht's combat power in the West was effectively shattered, entire divisions ceased to exist, and equipment that had taken years to produce was abandoned or destroyed. The road to Germany was open. The final collapse of Nazi Germany in May 1945 resulted from relentless pressure from multiple directions: Soviet forces advancing from the east, Allied strategic bombers crippling German industry from the air, and Anglo-American armies pushing into Germany from the west. Yet the decisive breakthrough that made all this possible began with a sergeant from New Jersey figuring out how to cut through a hedge using scrap steel and ingenuity. Curtis Cullen's story is ultimately about ordinary people confronting extraordinary challenges and refusing to accept that problems are insurmountable. It's about an organizational culture that values results over rank, and a practical American tradition of hands-on problem-solving, the belief that any obstacle can be overcome with careful thought and improvisation. It's about the decisive impact that individual initiative can have when leaders recognize promising ideas and act swiftly. The steel prongs welded to the front of a Sherman tank in July 1944 did more than cut through hedgerows. They broke a 6-week stalemate, undermined German confidence in their defensive strategy, opened the route from Normandy to Paris, and paved the way to Germany. On that July afternoon, when Omar Bradley watched a Sherman tank plow through a hedge, he witnessed a turning point as pivotal as any major battle. The solution was, as Bradley later noted, absurdly simple, so simple it had eluded an entire army for more than 5 weeks. Yet simplicity did not diminish its importance. Often, the best solutions are the simplest, and the most effective weapons are those that address the immediate problem. The Rhino tanks rolled across France in the summer and autumn of 1944, their steel prongs cutting through obstacles that had seemed insurmountable, restoring mobility to American armor and enabling the rapid advance that carried Allied forces from Normandy to Germany. They were improvised devices, fashioned from scrap metal by resourceful soldiers fighting a war that had to be won. They added no additional firepower, required no advanced technology, and relied on no exotic materials, simply welded steel prongs that worked. In war, that is all that matters. Curtis Cullen never sought recognition for his invention. He repeatedly tried to share credit with the man whose casual suggestion had sparked the idea, though that individual's identity is lost to history. Cullen returned to civilian life after the war, working quietly as a salesman, raising a family, and rarely discussing his wartime service. Yet history remembers him. Military historians remember him. Tankers who relied on his device and survived battles they might otherwise have lost remember him. His innovation continues to be taught as a lesson in initiative, ingenuity, and practical problem-solving. The greatest weapons are not always the most powerful or advanced, they are the ones that solve the problem at hand. Created by ordinary people with extraordinary insight, tested under the most challenging conditions, and implemented with speed and determination, the story of the Rhino tanks and the sergeant who invented them stands as a lasting testament to the power of innovation, the value of organizational flexibility, and the profound impact that individual initiative can have when leaders recognize and act on good ideas. Curtis Cullen's simple welding trick broke the Normandy Stalemate, altered the course of World War II, and helped liberate a continent. That legacy deserves to be remembered.